All right, hello. I wanted to look at a couple of the examples from the quiz the other day. Actually, I guess it wasn't really a quiz, the progress check from the other day, dealing with different series. And different people had different questions. I had kind of a bank of questions that it was pulled from. So you may have seen some of these, you may not have seen all of these. But anyway, hopefully, should have been a pretty nice mix of some pretty basic ones and ones that went a little bit farther. So even if you haven't seen these, I think they're worth looking at because certainly on future activities, we'll have to deal with all of these. I noticed a theme in the two types of questions that people were missing most often. We were missing a lot of questions dealing with the nth term test, which I think I kind of warned everybody. That tends to be the thing that burns people if you don't get in the habit of checking for it. It's the easiest thing to check for, but if you don't do it every time, you get burned. And number two, the properties of series. If you didn't read the PowerPoint that had the outline of all the different series rules in it, you didn't look at the properties, you might have missed a property that was pretty doggone important. So let's take a look at a couple of these now. All right, the first one here, it's the sum of 1 plus 1/3 to the n. By the way, I probably really should have had parentheses around this whole thing. It's the sum of the whole thing. However, that n doesn't make any sense if it's not linked with the sum. So I think people knew that. Remember, the first thing you always want to check is the nth term test, because if you're not adding terms that eventually approach zero as you go farther out, it doesn't matter anyway. And so in this particular case, if you take the limit as n goes to infinity of 1 plus 1/3 to the n, well, think about it. If you multiply 1/3 times 1/3 times 1/3 times 1/3, very quickly, this whole thing is going to approach zero. Okay. And anyway, 1 plus 0 is going to approach 1. So if you just started listing values here, they'd get closer and closer to 1. And so if you go out to infinity and you're adding something real close to 1 and something close to 1 and something close to 1 and so on, it's never going to add up to any kind of sum. And as a result, that is a divergent series. Now remember, the nth term test does not tell you that a series is convergent. So, just because they just do approach doesn't necessarily mean that it converges. So anyway, it does tell you that a series is divergent. Okay. Number two, in the table of different rules we had a rule that said that the sum of a series is equal to the sum of two individual series. So in number two, this is really the sum of 2/3 to the n, which is a convergent geometric series, plus the sum of 7/2 to the n. And notice 7/2 is 3.5. That's an increasing series, so that one is going to diverge. And actually, we see the same kind of thing in the fourth example down there at the bottom. That's also the sum of two series. So that is going to be the sum of, you could factor out a 2 there, and you could make that a 2/5 to the n plus the sum of, it's a p series actually, it's 4/3n to the fourth. You could factor out the 4/3 there, and they have 1/n to the fourth, which is a convergent p series. So this converges, it adds up to something. This converges, it adds up to something. So if the two parts are both convergent, it's going to converge. And meanwhile, if the two parts did not both converge, it would be divergent. If even one of the two diverges, the whole thing will diverge. Okay. And last one here, again, the nth term test comes back. You always want to check and make sure the individual terms are approaching zero as you go farther out. And if you take the limit of this as n approaches infinity, we know that really the n third terms are all that matter, right? Because they're going to grow much faster as we put in bigger and bigger numbers. And so if you look at the limit of 2n squared over 3n squared, this is going to approach 2/3. So if you just kept listing values, if you put this expression in a table, you start listing values, they get closer and closer to 2/3. You keep adding 2/3 and 2/3 and 2/3 and 2/3, adds up to infinity. So that is a divergent series. So again, cannot stress it enough. Make sure that you're checking to see if the individual terms approach zero before you get started. A lot of these ones that don't match any of the patterns don't need to match any of the patterns because they literally are not going to approach zero, which means it's going to be divergent and these tests are going to fail. So make sure you're checking for that. Hope that helps on a couple of those tougher quiz questions.